So multiplying rational expressions, really straightforward today, really straightforward. The only thing we're adding is we have multiplying in the first lesson, and I broke it into two parts, and the second one is division. But the division one you're going to find is very similar. So it's practice today on factoring and canceling. We can only cancel things that are identical. So anything in the top can cancel with anything in the bottom. So look, can the 2 or the 5 cancel with the 3 or the 7? No. And the x's can't cancel, so all you do is you multiply straight across. What's 2x times 5x? 10x squared. And 3 times 7, 21. Now, if something could have canceled, you would have. But it doesn't in this case. Look here. Is there an x by itself in the bottom that would cancel with this x? What is this x connected to? The plus 5. So that's a very strong bond. Okay? So the top, I just have 3x squared over 4 times x plus 5. So the whole idea today is just multiply across if things are possible and they don't cancel. If things cancel, we will. So let's look down here. You could have. I guess I can put or 3x squared over 4x plus 20. They're both correct. I would typically leave it, Josh, like the first one, because it's nice to have them already in factored form, which lets you cancel. All right, so let's look down here at part 2. Does any one of the 4 positions factor? What do you think? Which one factors of those 4? Sid? The 2x plus 1 factors?
Oh, wait, no.
Or does this factor?
That factors.
Okay. What are the factors of 4x squared minus 1? Can you think of them? Uh-huh. Well, is it a perfect square? Is that a perfect square? 1 times 1. Okay, and there's a minus in the middle, so this is the difference of 2 squares. Difference of 2 squares, remember, factors to conjugates. What are the conjugates that lead to that? Anybody? It's going to be something plus 1, something minus 1. But what? What times what is 4x squared? 2x. So 2x plus 1, 2x minus 1. Let's keep everything else written down. I have a 2x plus 1 up there. I have a 6x there and a 3 there. So your first step is going to be to try to factor everything completely. Now let's have a little canceling session. What's identical on the top and the bottom?
The 2x plus 1.
So those are gone. What else cancels? Can you see something else that cancels?
The 6 and the 3.
Yeah, the 6 and the 3. Now careful, that cancels to a 1. That cancels to a 2. You can cancel something that doesn't have an x because it's connected by multiplication. It's not connected to something by addition. Good question. Because remember on our practice quiz here, 8x squared over x plus 5. The x plus 5 was connected with addition, so it can only cancel with an x plus 5. But here, the 6x is connected with multiplication, so the 6 and the 3 can cancel. Does that make sense? All right, so let's see what we have is, what's left on the top? I have a 2 and an x. What's left on the bottom? 2x minus 1. Now I ask you another question. Can the 2x minus 1 cancel with the 2x anyway? Why not, Luke? There's a minus connected to it, so it doesn't cancel. So that's your answer. Boom. Factor, cancel things connected with multiplication. All right, here we go. Do any one of those 4 positions factor? Start me off. Sydney did the last one. Someone else. Brett, you got it. Take one of the 4. Which one factors? Okay, what does that factor to? times I can't hear what your words. No, it's okay. Think, what's the GCF between those two? It's okay. Luke's going to be quiet here. What's the GCF between 8 and 16? 8. Yeah. If Luke would be quiet, we could do this. All right, so I have an 8 and an x plus 2. Somebody else, a different position. Jalan.
I was just going to say to change that x squared minus 4 to x plus 2.
Okay, change that to its conjugates, x plus 2, x minus 2. The 8x really doesn't cancel, and the x minus 2 really doesn't cancel, or simplify. So, does anything cancel?
Can you cancel the 8 with
You can cancel the 8s, because they're connected with multiplication. Does anything else cancel? The x minus 2's cancel, because they're connected, and the x plus 2's cancel. What's left on the top?
1?
A 1. What's left on the bottom? An x. John, how'd you do it? Wow. It's always easier to factor first and then just look at your factors. If you start multiplying things out and making them larger, you're not probably going to see the factors. In this case, you would, because a lot of things cancel. But if they don't cancel, you won't see it. If you ended up with something, that didn't cancel, like this previous one in number 3, you might not have seen how it all worked out. Question, Jalan. All right, Josh?
So you had canceled all the things out, it still would cancel if you want.
Well, when things cancel, they typically cancel to 1s. So I have 1 times 1 times 1, which is 1. And I have 1 times x times 1 times 1, which is x.
If say the 1 was a bottom, so it should be 1.
Right. Right. All right, flip her over. Whenever you have a fraction times an expression, I want you to start by putting the expression over 1. So right now, put a line underneath the x squared minus x and put over 1. So we have a fraction times a fraction. So there's step 1. Now let's set it up in step 2 to factor. The 3 and the x don't factor, and the 1 doesn't factor, obviously. What goes into x squared minus x? Remember, 2 terms. You're looking for 2 options. Either it's the difference of 2 squares, or it's a GCF.
X minus x, x plus x.
X minus x and x plus x. That won't get you x at the back. Difference of 2 squares. This is a perfect square, but is minus x a perfect square? No. So, when that's the case, look for a GCF. Someone besides Sydney, Jalan, Luke, and Josh. What's the GCF there? No, someone besides those people. What's the GCF? Katie? Yeah, just an x. When you take out an x, what's left? X minus 1. All right, let's see what cancels. The x's cancel. What do those cancel to? 1. Does anything else cancel? Kyle?
Would you be able to cancel the 1 and the 1?
They would cancel to 1s, so we're okay there. So left on the top, I have 3 times 1, which is 3, times x minus 1, over 1 times 1, which is 1. Do I need to put it over 1?
No.
So I guess my answer would be 3 and x minus 1. So you're going to try to cancel whenever possible, and then simplify from there.
So it says like at the top the directions are factor and simplify each problem.
Uh-huh.
We need to simplify it so we would like factor it to 3x minus 3 to get the most simple form, or would we keep
Those would be comparable. Either one would be correct. I would prefer this one because it's clearer, but neither is right or wrong. They are both simplified. I didn't say factor completely and leave your answer in factored form. If I had said that, you would answer the red one. But if I just say simplify, either one's fine. All right, number 6. First thing, take this whole big long parentheses and put it over 1. Now, I need to teach you some shortcuts here. Does the 2x factor? I guess 2 times x. Does the x plus 3 factor? No. Over 1. Now here's my point. As you're doing your problems today, use the answers that you're given to solve the problem. You see that x plus 3 in the bottom? Justin, it's very likely that one of the factors in the top might be x plus 3. Let's see if it works. What is positive 3 times what is negative 15? Negative 5. What's negative 5 plus positive 3? So does it work? So if I went off to the side here and I said what multiplies to negative 15 that adds to negative 2, we would say negative 5 and 3. So I would put my parentheses, x minus 5, x plus 3. And our suspicions that positive 3 was one of the 2 factors is correct. So Abby, those x plus 3's cancel. Does anything else cancel? Nothing else is in the bottom, so it can't. So my answer is going to be 2 times x minus 5. As we learned on problem 5, we don't need to put that over 1. Could you multiply the 2x out? Yes, but you don't need to. So the premise would be, look for things, Abby, in the bottom that might help you see what the answers might be factored into for the top. All right, number 7. C squared minus 1 over 1, C minus 2, and 3C plus 3. Ladies, you go first. Pick one of the 4 to simplify. Top left, top right, bottom left. Ladies, which one you want to do? Bottom right? All right, Katie, what's bottom right?
3C plus.
Good. Gentlemen, back to you. 3 spots left. Which one are you going to do? Luke?
Top left.
Top left.
C plus 1.
C plus 1, C minus 1. Obviously the 1 doesn't go. The C minus 2 doesn't go. What's the only thing that cancels? Look closely. C plus 1. Does anything else cancel?
No.
So I guess my answer is C minus 1, C minus 2 over 3. Factor, cancel. Factor, cancel. Factor, cancel. All right, going from there. Which one of these 4 factors in any way, shape, or form? This would be Sam, Noah, Luke, Ryan, Hannah, Justin, or Haley. One of you guys. Factor one of these 4. Ryan? Bottom left. Okay.
2x minus 2 or 3.
Well, you're not going to have a minus there. It's 2 terms, but it's not a square. So when that happens, look for a GCF. Does a 2 go into both?
Yes.
Okay, so let's take out a 2. 2 times what is 4x?
What?
2 times what is 4x?
2.
Okay. And 2 times what is positive 6?
3.
So 2x plus 3. Okay? Haley?
Bottom right,
Bottom right.
the 3, and
Good. Okay, Ryan and Haley gave us the first two. Going from there, someone else from that group. Anything else factor? Top right. Sam, how's the top right factor?
3 times 2x plus 3.
Okay. Does the top left factor?
No.
No? All right. Canceling party here. Noah, take it away.
X minus 5, x minus 5, 2x plus 3.
Anything else?
3 cancel 3s.
Threes? So on the top I have 1 times 1 times 1. That's 1.
It's 1/2.
On the bottom I have 2 times 1 times 1 times 1. That's 2. We start with a complicated problem, we end up with 1/2. So when you're factoring, a couple key ideas. If there's two terms, look for a GCF first. Or look for the difference of two squares. Remember, those got to be the minus, and they both got to be squares if there's two terms. Second, look for a factor you already have to be an answer to one of your other factoring questions. If you have a 2x plus 3 in the bottom down here somewhere, it's highly likely, Drew, that you're going to get a 2x plus 3 somewhere in the top. Look for that. Okay? If you know a pitcher only has a fastball and a curveball, you know at some point he's going to probably throw you one of the two. Okay? So just look for those as ideas. All right, I want to do a quick practice on these specifically.